In 6.3, we're testing for parallelograms, and we're going to try to learn to recognize the conditions that ensure that a quadrilateral is a parallelogram. Of course, the quadrilateral is a four-sided figure, parallelogram is a four-sided figure, but how do we know? And it's not by looking. I mean, we don't just tell by looking. It doesn't just like, oh, it looks like a parallelogram. Not enough. And then we're going to prove that a set of points form a parallelogram in the coordinate plane. Here's some conditions for parallelograms. You're probably not going to be surprised by most of these because it's going to be stuff that you've seen before in elementary school, pre-algebra, so on. It says if both pairs of opposite sides are congruent, then it's a parallelogram. And so you see we've got those marked. We've got those marked. If both pairs of opposite sides are congruent, it's a parallelogram. Once you know it's a parallelogram, then everything you know about parallelograms is true. Once you know it is, then everything you know about one is true. The second condition or theorem is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is I said sides, it's angles. Because this one says sides. Anyway, then the quadrilateral is a parallelogram. So you can see opposite angles are congruent. 6.11 says if the diagonals bisect each other. If the diagonals bisect each other. So you can see this piece is congruent to this piece, and this piece is congruent to this piece. They bisect each other. Once you know, and that's what happens with diagonals of a diagonals of a parallelogram. Once you know it's a parallelogram, then you know everything else is true. And the last one is kind of interesting because it says if only one pair. Because up here we had both pairs, but here we've got one pair of opposite sides is both. Theirs are both parallel and congruent, right? So you can see that we have both the congruent mark and the parallel mark for sides A, B, and C, D. So I have this picture here. That says that these two sides are congruent and parallel. So if they're congruent and parallel, it says we're given that AB is equal to CD. That's what I just said. And two sides are parallel. Therefore, the diagonal AC is a transversal. And since alternate interior angles are congruent, right? And since this is congruent to itself, then by side, angle, side, the two triangles are congruent. Once you know the two triangles are congruent, then you can go back and say that corresponding angles are congruent. So then that gives you this congruent to this, which means opposite angles are congruent. And that's how we can ultimately get around to proving that ABCD is a parallelogram. Also, I should say that the opposite sides here are congruent. And if both pairs of opposite sides are congruent, or if both pairs of opposite angles are congruent, then we saw that here. That proves parallelogram. So let's do some problems. To determine whether the quadrilateral is a parallelogram, justify your answer. Well, here we have the opposite sides left, right are congruent. The opposite sides top, bottom are congruent. So, yes, it is. It says justify your answer. What I have to do is go back up here and look and see when opposite sides, this is 6, 9. Sorry, didn't mean to ugly that up. This is 6, 9. Then that does it. And so their answer is They don't call it 6, 9, but they talk about the same stuff. If both pairs, you can see all that's there. So it says, what method would prove the quadrilateral is a parallelogram? Well, we already know which method. They tell us these are both 15, and they tell us they are parallel. So it says both pairs of opposite sides are parallel. Well, we don't know that about these two. They can look it, but we don't know it. This says both pairs of opposite sides are congruent. Well, these may look it, but we don't know. This says both pairs of opposite angles are congruent. They may look it, but we don't know. They may look it, but we don't know. D, we know. One pair of opposite sides is both parallel, right, little red arrows, and congruent, the 15s. So it's D. This is what we call a scissor lift. They even got the name written there. It says scissor lifts, like the platform shown, are commonly applied to tools intended to lift heavy items. In the diagram, these two angles are congruent, and these two angles are congruent. Explain why the consecutive angles will always be supplementary regardless of the height of the platform. Well, what we're able to say is because both pairs of opposite angles are congruent, we can say this is a parallelogram. And because it's a parallelogram, let me just kind of draw that for you. Let me draw these two just as an example, cut by transversal. Then this angle here and this angle here are consecutive interiors, and consecutive interiors add up to 180. They're supplementary. It's required. When the two lines are parallel, cut by transversal. That's how that works. And I'm sure that's kind of the blah, blah, blah that you see there. All right. The diagram shows a car jack used to raise a car from the ground. In the diagram, AD is congruent to BC. Opposite sides are congruent. And AB is congruent to DC. Opposite sides are congruent. Based on this information, which statement will be true regardless of the height of the jack? Well, it says these two are equal. Here's A, here's B. We don't have anything that says such. We know they're supplementary because it'll be consecutive, A and B, but we can't say this, so it's not the answer. This says that angle A and angle C are congruent. Here's angle A, here's angle C. And it doesn't matter what we do, if we squeeze this thing and make it go further apart or bring it down and make it go closer together, you're not going to get A and C to not be congruent. So the answer is B. We could have gone on through the rest of those. A little math here about that. Little math. It says find X and Y so that the quadrilateral is a parallelogram. If it's going to be a parallelogram, these two would have to be congruent. And these two would have to be congruent. So I'm going to work with that. And I'm going to say top 4x minus 1, bottom 3 times the quantity x plus 2. Those two things have to be equal. Opposite sides are congruent. So 4x minus 1 is equal to 3x plus 6, distributive property. So I'm going to pull the 3x over and make it x. I'm going to send the 1 across and make it 7. And so x is 7. I could plug that back in each of those and make sure it really did work. They would both be 27 if I did. To do the y, the left side and the right side, The right side is 4y minus 2, and that's equal 3 times y plus 1. So 4y minus 2 is equal, little distributive property, 3y plus 3. So I'm going to pull the 3 across, 3y across, and be subtraction, 4y minus 3y. Send the 2 over, it'll be addition, and that's what that is. Plug the 5 in if I want to check and make sure, and both those sides are 18. They found the 7, they found the 5, they said what we said. It says find M so that the quadrilateral is a parallelogram. Well, one of our theorems says if you can show parallel, and you can see that's what those little red arrows mean. If you can show parallel of a pair of sides, and you can also congruent of that same pair, then you've got a parallelogram. So we're saying that the 4m plus 2 would have to be equal to the 3m plus 8. Subtract 3m from both sides. Subtract 2 from both sides. M is 6. That's the m that makes the quadrilateral a parallelogram. 6. So this sort of just re-says the stuff that we've seen. This is the stuff that we've seen. And we're going to do that prove it's coordinate geometry is what we're doing, right? Coordinate geometry. So we're going to prove. Remember, there's really 4 ways to prove. That's based on that. 4 ways to prove it's quadrilateral. The quadrilateral is a parallelogram. So we're going to work with this. You can have opposite angles congruent, opposite sides congruent, both pairs. You can have one pair that's both congruent and parallel, and that's how we can do it. So we've got this picture here with this quadrilateral given the points that they gave us. It says determine whether it's a quadrilateral, or determine whether the quadrilateral is a parallelogram. There it is. Justify your answer by using the slope formula. Okay, so I could use the slope formula. Slope formula could be used to prove parallel. What I'm going to do in this case, because I don't want to use the slope formula, is I'm going to do rise 2, run 1, 2, 3, 4. If I rise 2 and run 4, the slope is 1/2. For this side. For this side, I rise 2 and I run 4. Rise 2, run 4. The same slope. So are what is effectively the top and bottom sides parallel? Yes, they have the same slope. Next, I'll try these two sides to see if they're parallel. And so I rise 1, 2, 3, 4, run 1. Rise 4, run 1. Rise 1, 2, 3, 4, run 1. Rise 4, run 1. The slope of those two are both 4. So since both pairs of opposite sides are parallel, they have the same slopes. All right. They went through that like we did. Since that's true, then the quadrilateral is a parallelogram, since opposite sides have the same slope. Another problem, a similar story. If we do E is at negative 2, 2. F is at 2, 0. G is at 1, negative 5. And H is at negative 3, negative 2. I'm going to do one thing, and I'm going to move my G letter or my F letter because I just don't want it in that place. So here's what I'm going to show you. This is pretty quick. These two sides here, if you rise 1, 2, 3, 4, round 1, slope would be 4. 4 over 1. Rise 1, 2, 3, 4, 5, round 1, slope would be 5. Are those parallel? No. Answer B. Trying to find where that. Yeah, that's it. We're not going to do the proof.